happy to be here this afternoon. WSO2 has been a great partner for us since we got started. We have been doing a lot of collaborative work together. And what I wanted to talk a little bit about today was what does it mean to be a lean developer? What is the concept of continuous development? As a company, Codenvy, we're about a year and a half old. We were founded in 2013, but a lot of the roots of what we got started doing happened in 2009. And we are actually a spin-off from a French company called XO Platform. They're based out of Paris. And they had built some IP along the way to build a cloud-based IDE. And they had an IDE that was entirely in the browser, and it did fairly well. It supported Java, it supported Python, PHP. There was a number of items there that it supported. We took that IP, and we really felt that there was a tremendous opportunity to rethink how development was done in its entirety, and to actually have a meaningful and lasting impact on the workflow and processes that enterprises use to build applications. And that's what I'm going to talk a little bit about today. They gave a great background on me, a little bit about myself. I've been a Java guy since '97. I taught courses on it to corporations even before Java EE existed. In the past years, I've mostly done venture capital work and investments, but I work exclusively in developer markets and middleware. And so the venture capital company that I'm a part of actually invested in WSO2. I've done other investments as well. I do some board work, but I spend the bulk of my time working on Codenvy here. What got me inspired by it was that I had been hands-on for many years, and then I got to product management, and I was hands-off. I was still relatively technical. I was incredibly dangerous. My engineers despised me because I could say, why doesn't it work like this? You should just try to flip this switch and it should be okay. And of course, I was always wrong. After many years of management, I took a hiatus, and I wanted to get back into coding. And for some reason, it took me more than a week to get a Hello World Java application up and running in Eclipse with Tomcat. Never mind Java EE, which was the topic of which one of my books was based upon. And it was incredibly frustrating to me that in a matter of 8 years from since when I had stopped programming to the time that I got reconstituted into it again, that it took all this tremendous amount of energy and effort just to get what is effectively a hello world. And so there's a ton of inefficiency in development today because you spend a lot of your time going through steps like this, which is, this is the quick start guide to doing Eclipse with Java 7 on Tomcat there. And you know, that's all manual steps. And in fact, you know, at the companies that I've worked for every development team, whatever project you were working on, we all had some sort of wiki page, and you would go to that wiki page, and there would be somewhere between 40 and 50 steps of everything that the developer needs to do. And if they follow the steps just right, and if their authorization permissions are just right, whatever it is, right, if you do it, you know, and follow it to the letter, you might have a developer environment that's working that you can compile and run afterwards. And that's just kind of ridiculous there. So this got me frustrated, and I knew that the power of cloud could be used to solve this. When we started diving in a little bit deeper, we saw that the problem was more significant. The amount of time that goes into configuration management of your developer environment is a lot more than just the effort in setting it up. It's a tax, it's a plaque that builds up over time. There was actually a fascinating study done about a year ago with Electric Cloud and LinkedIn. There were 1,200 professional engineers. They were interviewed, and they were profiled on how they spend their time each week, and they reported back on average that they spent about 12.9 hours per week dealing with administrative and configuration issues on their environments themselves. I thought this was a stunning statistic, but if we were to decompose that time and take a look at it, it's actually not all that unreasonable. When you think about what a developer does, All these tasks on the left are things that take them time and they do them repeatedly throughout the day. New projects, switching between true active projects, changing a branch. These are all things where you have to go and do some amount of configuration to constitute that environment to the point where you can compile it and run it. It's a non-zero amount of time. You update your tools and plugins. New version of your IDE, new version of all the plugins, maybe the ALM tools. It gets interesting. If you are on a machine and you give that machine an inefficient amount of RAM or an inefficient amount of CPU, and then you hit compile, right, it's going to take a long time, longer than necessary. So there's a compilation lag. If you've got to do code reviews, the person who is going to do the review on behalf of someone else has to get their environment set up. So that's another configuration event. If you're using continuous integration and someone checks in the code and the build fails, I mean, it happens, even in our own company, this happens frequently. I mean, just last night, Roman was beating his head against the wall because one of our engineers went home and the build was failed, right? And so if you're in charge of investigating that, you have to reconstitute an environment. It's more configuration. If you're really greedy and you're doing some hardcore work, you can easily start throttling your computer. So you have to do a 10-minute compilation, and you send off on this build, and you're doing it locally. Now you're thrashing your system. You try editing those files. You try running your web browser. Now the system's in conflict with each other, and everything else slows down. Wasted time. Synchronizing the VM, if you're using Vagrant or some other some other local VM technology, you've got to download these VMs. You've got to synchronize it with the master. You've got to deal with merge conflicts. The time adds up. Developers do hundreds of these events a week, and the tax is pretty significant. When you get to the team level, now you've got unnecessary amounts of hardware. I have 100 developers, right? And if they're doing all their development on the desktop, you buy them $3,500 machines so they can each get 16 gigabytes of RAM, 2 terabytes of data drive, maybe a SSD drive, high bandwidth. But at any given point in time, is all that hardware being utilized? They use it in incredibly short bursts, and then they go away. And when they go away, those machines are just sitting there idle, unless you've allowed your developers to use SETI, and then while those machines are sitting idle, they're out there looking for extraterrestrial life instead, right? So your spending, your CapEx budget is getting allocated inefficiently there. You have tribal knowledge. There's usually a small percentage of people who have an abnormal percentage of knowledge and awareness of the environment. So it's great for them. They're very efficient with setting these things up. But then the newbie comes along. He gets into a mistake. Now that guy, your senior guy, has to stop what he's doing. I do this to Roman all the time. Roman, help me out. Stop what you're doing. I've got an issue. And he's got to help him, right? This is a tax. Most of your developers want to use multiple machines, so now you have to take the time to get it from one machine to the next. And then there's oftentimes incompatibilities. It just doesn't copy over. You've got environmental technical debt. The older the project gets, the harder it is to reconstitute it. Right? Have you gone back to a project that's 4 years old and then tried to recompile it? Everybody's brain is a little bit fuzzy. Right? When we were doing it, it was just right, but then it's a little bit fuzzy. Not to mention, you put all these machines, you give all the developers these desktops, they copy the code onto the desktop, they install a bunch of software on there. Now you've got a security risk. You've got all this IP. You can't monitor what that IP is doing unless you install monitoring software, which your developers are going to love. Right? And you've increased the number of threat vectors externally as well, because developers just like to install everything that's on here. So this is a non-trivial problem. It's actually a massive problem, but no one's dealing with it. So we make developer environment clouds. Our business is we make them fast, secure, extensible, and instant. And I'm here to say that we believe that the technology is now crossed the threshold where we can make developer environments in the cloud faster than what they are on the desktop. It's only a matter of time here. Our business model is we're going to have a public cloud. We also make this entire cloud available on-premise, installable. It's embedded. It's going to be embedded with App Factory as well. We'll show a demo here in a second. But a developer environment is this nice, nifty little box here. You know, it's not just the IDE. You got to have the project, the code, the client to get Subversion or Perforce, whatever SCM tool you're using. You got to have code assistance for the autocomplete, the refactoring. You have to have a builder which compiles, unit tests, packages, creates the binaries. You have to have a runner so that the developer can run the application and debug it. So that means you have to be able to install databases and app servers and frameworks. You got to be able to deploy the code. You have to connect it to your issue management and service desk tools. And then the developer also has all their own plugins that they use to make them more productive. A developer's environment is a miniature data center in and of itself. We make a developer environment cloud, which means that what we do is we enable instant provisioning of a developer environment. Whether you want 1, 10, or 1,000,000, instantly provision these environments according to a recipe. There's nothing to install, nothing to download, nothing to maintain. Environments are recipe-driven. That once you have a configuration for it, it will always be created in the same exact way, time and time again. Instead of having an environment for every person, now you can create an environment for every task. 1 per issue, 1 per job, 1 per developer, 1 per project, because the cost to create an environment goes to 0. It's frictionless. Once you do that, then it's controllable. You can use any IDE that you want, including Eclipse and IntelliJ, and your existing ALM tools. But we also provide a browser-based IDE. Once it's in the cloud and it's managed as an object, we can clone them, we can embed them, we can share them. You can manage privacy. Make the environment public, make it private, control who has access to it as well, right? And then scale it. Add CPU and RAM, right? If you've got a big project, we're doing a project with Epic Games. They make this big old a gaming engine in 3D. It takes 45 minutes to compile with 24 gigabytes of RAM, right? So in those environments, they want to be able to scale up to about 50 gigabytes of RAM with quad-core CPUs. They should be able to flip a switch, and then for all the projects that match that criteria, you get just enough resources that are there. But in addition to scaling it up, it's also about maximizing the use of the hardware that's available. So there's no reason to have any hardware that's idle. Let's use all the RAM appropriately, all the CPU. Let's maximize density with minimum hardware for large populations. Connect it to your identity and firewall system so it's part of your enterprise flow. And then once you've done that, you can manage, analyze, and extend. You can quarantine the IP. You can track time automatically. We've got an analytics system. And then automate internal processes. So with that, the way we do this is that we use this technology called factories that we've created. And essentially what a factory is it takes all of this and it wraps it up into a very simple URL. And inside this URL is all the encoding necessary to launch the project there. So, ooh, that was, yeah, that was loud. So is the screen showing up? Great, okay. So, here's a website. This is angularjs.org website, right? And they've got some examples down here. Here's a basic example. So this button is mapping to one of our staging servers, and it's one of our factories, right? You can see the fancy URL. And there's just a bunch of codes along here. Those codes give us an instruct. This is a staging server. That's why I shouldn't have gone there. All right, let's go to a different one. One of these, sorry. Yeah, okay, that's a good one. So this is one on Chef. All right? But there was a code there. It's launching an environment. And what it's doing is it actually created a whole new environment. If I were to go back in here, click that again, I've got a second environment that's getting created. You can see way up top there, if you can read that, it says that it's a temporary environment, because I'm not logged in, it doesn't know who I am, and that I've actually got 2 developer environments in 2 separate tabs running on a server-side system that's out there. They each have their own resource allocation, and inside of them, we have a full development environment. There's a project space, the project code. There is a compiler, we call it builder in here, which includes unit tests, compilation, packaging. We have a runner. The runner will create an image and execute a project as well. And you've got your SCM tools and plugins up here as well. So we could make modifications, commit these, add these, track them if you want. I can come here, I can click Run. And this is actually running a Chef script. And Chef is a sysadmin tool that's used to configure a virtual machine. It's starting this up. In order to start it, it needs to build a new image. Running a little slow today. Should have gone to... They did say that they were going to run some load tests on this server. So let me go to let's get another one going here. Another server. All right, this one actually ran. It was a little slow today. But in order to do the run, it actually went and created the image, executed the process in there, right? It's inside. We have a lot more interesting things we can do, so we'll come back into this one. We'll create a new project here. Just for fun, we'll do a desktop app. Go run. You can see that it's launched parallel threads, so behind the scenes it's grabbing whatever software dependencies it requires, and now it's building the image. Once the image is done, it gives me a URL. So this is a desktop app, so it's created a completely separate image. And this desktop app is running a Swing application here. So we haven't left the browser. You can stop this. Come in here, open up some code. Close that out. It's a full Java editor, right? So I can come in here, I can do frame, I can hit Control Space. It'll give me autocomplete off this. It's taking a little bit of time here because this is the first autocomplete that this application has done. So it sent the request off to the server, and then it has to process it over here and downloads it. So now I've got those options that are here. If I did it a second time, it's instant because it's cached as well. Once I wanted to, I could initialize this repository, bring up a share window, and then I can create a factory, which is one of our fancy cloning capabilities, copy that, put it into the browser, and now I've got another clone of the very same environment with the modification I've made as well. So when you go into a SaaS developer environment, you have the richness of the existing tool set. You can use your existing ID and interface with the remote system, but cloning, embedding, and sharing becomes near frictionless. Right? And when they become near frictionless, you can launch an environment nearly instantaneously in a number of configurations that's there. So there's much more to what we're doing. We're about 50 people, 40 of them in engineering. We're going to be shipping this particular version of the product and opening it up for production use starting in Q3. We're in alpha now. This version that you see here is an alpha. But we have an OEM with WSO2, and this will be embedded as part of App Factory, so every project can have this as well. To wrap up, get a good flow here. Great. To wrap up, that was the simplest on the configuration side, but you can actually make these things incredibly fast, secure, and extensible. There's a number of things that we're doing where you can cache dependencies at multiple layers. You can do separation processing. So when you're in a system like this, we actually separate builders, runners, editors, code assistants. They go onto separate physical nodes. So to a developer, there's no thrashing possibility. When you're on your single computer, all those functions are competing with each other at the same time for the same resources. We divide them up. So you get a much stronger overall individual user experience, and it's a non-blocking capability. Because it's cloud, we're actually able to add compilers, builders, packagers, unit testers, runner images, and we're working hard to populate our own database, but we believe that within a year or so we could have hundreds, if not thousands, of configurations that are prepared out of the box. And it can be very simple things like Java Hello World, or incredible richness and depth like a complete WSO2 platform stack as well. There's no limits to the sort of configuration that you can do. On the security side, we talked about what happens once it goes centralized. You can lock it down, you can quarantine it, you can restrict access, you can apply behavioral restrictions. So things like disabling certain menu items for certain users are all possible. And it's extensible to the point where we have written this as an SDK that follows an architecture that's nearly identical to what Eclipse did for the desktop. And so writing plugins follows a very similar format. And so any of the functionality in the system can be completely tailored. And there's a way to create packaged extensions that's there. So what we've built is essentially a set of 50 extensions. The IDE that you saw was these plugin blocks that were packaged up. We have some customers already. We've done a pretty good job. Our monetization model is that we're going to make most of the software open source, following the WSO2 leadership position here. And in our public cloud, we'll sell RAM, increasing levels of RAM for developers, and we'll sell support subscriptions for the on-premise installations there. And with that, I want to thank you. I've got 2 seconds left, and open it up for any questions that you've got. Yes, sir. I can't see, so if you have questions, just yell it out.
Is there a pair programming feature built in? Because I think it would be fine.
So in the version we have online today, which is our legacy generation, that's about 4 years old, yeah, there's a multi-cursor ability. So if 2 people go into the same environment at the same time, you get the multi-cursor and you can see what they're doing. That sort of capability proves to be very difficult to scale. So in this next generation system, we do support multiple people in the same environment at the same time. You just can't see what they're doing on that. But we'll add it back in. We have work to do to make it, internet scale quality on that. Yep. All right. Well, I know we all want our break. I want my break too. Me and my team will be around. We're happy to answer any questions that you've got. And the WSO2 team can get you demos of our integration with App Factory as well. Thank you, and enjoy the conference.